In this video, we're going to start section 4.4, which is looking at the graphs of secant and cosecant. So I'm going to start by trying to graph y equals secant of x. And in doing that, I'm going to use the fact that that's the reciprocal of cosine of x. So what I'm going to do is I'm going to start by drawing cosine of x, but I'm going to graph it as a dotted curve because points on the graph of cosine are not, in general, going to be points on the graph of secant. And so I don't want it to look like, if I draw things with a solid line, that like that's part of my answer. That's just going to be sort of a helper for me to figure out what the graph of this looks like. So if I were graphing cosine, I would mark off my quadrantal angles, pi over 2, pi, 3 pi over 2, and 2 pi. I know my high values are 1, my low values are -1, and cosine, remember, starts at a high value of 1. So it goes 1, 0, -1, 0, 1, and I'm just going to connect those points with a dotted curve. Okay. Okay, so now I want to take a look at what the reciprocal of cosine is going to look like. And the first thing I'm going to do is I'm going to recognize that that's going to be undefined whenever cosine is 0. So at all of these places where cosine crosses the x-axis, its value is 0. Secant is going to be undefined. And what's going to happen there is very similar to what happened when tangent and cotangent were undefined. What happens is as I get close to these points, the top is 1, the bottom is just really, really small. Sometimes it's a small positive number, and sometimes it's a small negative number. But when I divide by something small, remember, I get something big. Think about dividing by 1/1,000,000th. That's equivalent to multiplying by 1 billion. Okay. So when things get really big, we're going to have vertical asymptotes. So at all of these places where cosine is 0, which are odd multiples of pi over 2, we're going to have a vertical asymptote for the graph of secant. And remember, with tangent and cotangent, we learned that when we're graphing something that has asymptotes, it's good form to just start and end with an asymptote. So I don't really want to start at 0 because that's not the location of an asymptote for this. So if I follow this cosine graph a little to the left, I can see that negative pi over 2 would be the next place where it was equal to 0. And so I can draw an asymptote there. And then the next place here, this would be 5 pi over 2. There would be an asymptote here as well. Okay, so now what I want to do is see what happens in between each of these pairs of asymptotes. Now, in between each pair of asymptotes, I have what I'm going to refer to as a bump. These are bumps. That's not formal mathematical terminology. But notice it here, this bump is positive. Now, I know when I take the reciprocal of something positive, I'm going to get something positive. Here, this bump is negative. And when I take the reciprocal of something negative, I'm going to get something negative. So between these two asymptotes, my graph will be positive. Between these asymptotes, my graph will be negative, then positive. We're just going to alternate. Okay. All right. Now, if I look at the pattern here, for cosine, we go from a small positive up to a high point at 1, down to a small positive again. Now, when I take the reciprocal, small stuff becomes big, and big stuff becomes small. So what's going to happen is instead of going from small to the biggest value to small, we're going to go from big down to a smallest value back to big. Okay. And the smallest value of secant will be the reciprocal of 1, which happens to just be 1. So at this one point, that's the one point that's going to be on the graph of both cosine and secant in this interval. And so secant's going to look something like this. I'm going to get a similar pattern over here, talking just in terms of absolute values. We go from a small absolute value to our biggest absolute value back to small. So it's going to go from big to its smallest absolute value, which will correspond to a high point because this is the least negative point. And again, the two graphs are going to just touch here because the reciprocal of -1 is -1. Okay. I like to refer to this process as flipping the bumps. Okay, so we just go and we flip the bumps. And so what we're going to get is a sequence of alternating curves. These kind of look like a curve that we would call a parabola. They're not actually parabolas. Parabolas would be things like the graph of y equals x squared, and they're infinitely wide. These aren't infinitely wide because they're squashed in between these asymptotes. But we get these alternating U-shaped curves. Okay. All right. Now, if I want to think about what the period of this thing is, that's going to be the length of the interval it takes for it to do its thing one full time. Its thing seems to be one positive u followed by one negative u. So the period is the same as cosine. It's going to be 2 pi. So what I have graphed here is 1.5 periods. This would be one full period. This is starting the next period. Okay. So when you're asked to graph things in homework and on quizzes and exams, make sure you read the directions and sketch the appropriate number of periods. For graphs that have asymptotes, I will always specify, I want you to graph exactly this many periods. Let's just suppose I'd ask for exactly, exactly 2 periods. So then I just keep going here until I hit the next asymptote, which would be at 7 pi over 2. And that would be exactly 2 periods of secant. Okay, what we're going to do next is take a look at the graph of y equals cosecant of x, which is the reciprocal of sine of x. I'll do that in the next video, but what I want you to do is turn off this video, and before you watch video 2, see if you can mimic what we did here. Start by graphing sine as a dotted function, and then figure out where your asymptotes are, flip the bumps, and you should have your graph of cosecant. And I want you to graph exactly 2 periods of cosecant of x. All right, we'll review that together in the next video.